All right, good morning, or good afternoon, rather. So we had a couple of questions about how to solve nonlinear equations and how to deal with graphing conic sections, okay? So why don't we try a couple of these? Why don't we try the conic sections first, and we can move into the graphing or the solving nonlinear equations, okay? So we have like an x squared over an a squared plus a y squared over a b squared is equal to 1. This, because there's a plus here, and both of the exponents are positive, or 2's rather, this is the equation of ellipse, all right? So an example might be something like x squared, say, over 25 plus y squared over 36, how about 9 equals 1. All right. So if I was going to graph this thing, what you're going to do is you're going to use method of intercepts. Pretty much that involves letting one variable equal 0 and then solving for the other and then swapping it so that both variables have a turn of being 0. Okay, so in this case, like, let's set y equal to 0. Okay, so we're going to have x squared over 25 is equal to 1. We have x squared is equal to 25, and we have x is equal to 2 plus or minus 5. Okay, the slightly more involved thing you're going to do, okay, we could have x minus h squared over 25 plus y minus k squared over 9 is equal to 1. In this case, you're not going to set y equal to 0, you're going to set y equal to k. Okay, so the center would be hk. All right, we set y equal to k, so this term gets knocked out. Okay, this term goes to 0. So that's really the point here. It's not 0 specifically, it's whatever value will make this part here 0. When we change terms, it'll be whatever x equals h, so this thing gets knocked out. Okay, so just be careful in case you have an offset, a non-origin centered ellipse or hyperbola here. Okay, so that's what we have. Oops, go back down to drawing. So here we have x plus or minus 5. Then in the second piece, right, we're going to set x equal to 0, okay, or x equals h in the second case. Okay, we're going to have y squared equal over 9 equals 1. Y squared is equal to 9. Y is equal to plus or minus 3. Okay, so what you're going to do here, okay, y is 1, 2, 3. 1, 2, 3, x was 0. When y was 0, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So my vertices, okay, which ones are the vertices? Okay, the long axis is called the major axis. So in this case, the x part would be the major axis. Major axis is x is equal to 0, because that's the line that it's on. The transverse axis, minor axis, that's going to be the short one, so that's y. Okay. So the vertices, okay, are along the major axis. So the vertices here are plus or minus 5, 0. Okay. I'm not really sure what the other points are called, okay, but the minor axis endpoints is 0 plus or minus 3. Okay, so that's what we're going to have there. So we go ahead and try to make a drawing that looks like an ellipse here. Call that close enough. If you're asked for foci, okay, where's the foci? There's a formula. Now, if you're in my class, I provided the formula. If I asked you for the focus, I provided this to you because it's late in the semester and I didn't want to give you another formula to memorize, but this is going to be c squared is equal to 25 minus 9. Okay, a is always the big one. Okay, no matter if it's under X or under Y, I always just make A the big one. Okay. So here we have squared is equal to 16. C would be plus or minus 4. Now this is plus or minus 4 from the center. Okay, so if you have foci that the ellipse that's off here somewhere, it's going to be plus or minus 4 from the center along major axis. Yeah, it's a lot easier to kind of do in practice and make a picture than it is to explain in words. Try to do everything with this, but the foci is going to be plus or minus 4, 0. Okay, so whatever you come up with here, it's along the major axis on the center, from the center. Okay, so there we have that. All right. I don't believe I ever asked eccentricity. That's part of ellipses as well. I've never asked it. I've never used it. It worked a place where we put satellites up in orbit. That word never came up. Okay, at least not with regards to ellipses and orbits. We just never did that. Okay, I'm sure astronomy does have that. Okay, but it's not something that you would say, well, let's memorize this. Okay, I'm not going to do that. What about hyperbolas? Okay, so that's pretty much all there really is to it for ellipses. Okay, foci would be here. Okay, foci would be 2, 3, 4. Oh, 4. Never mind this. 4. Okay. Now for hyperbolas, okay, what we're going to have is we're going to have a plus or minus. There could be a sign here, okay, SIGN sign, and then minus plus y squared over b squared is equal to 1. That's the standard form, all right? All this is trying to say is that if x is plus, y is minus. If x is minus, then y is plus. Okay, it's the only thing that we're really trying to say here. They have to have opposite signs. Okay. Now, the vertex will be the vertices, I should say, because there's always 2 of them. Okay, the vertex is going to be in line with the variable that is positive. It's in line with the positive variable. So for example, if we have an x squared over 16 minus a y squared over 4 equals 1, the vertices are going to be along the x. Okay, vertices. Okay. And if we had something like negative x squared over 25 plus y squared 64 equals 1, then the vertices are going to be in the y direction. Okay, so that's how you tell which way is going to be which. Okay, so if we have an A and a B here, look at A. Okay, what we're going to have is, again, method of intercepts. Okay, it's a very powerful tool for graphing. Okay, so set x equal to 0 and ignore the negative. Okay, so we get y squared over 4 equals 1. So we have x squared is equal to 2, y is equal to plus or minus, I'm sorry, this is a 4 still, y is equal to plus or minus 2. Set y equal to 0. Okay, we have x squared over, what do we have here? 16 equals 1. We have x squared is equal to 16, x is equal to plus or minus 4. Okay, so when I go to graph this, okay, we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, and 1, 2. Okay, Now, the vertices are going to be here and there. Okay? -4, +4 for x's. But the other thing we have to deal with is that there's always an asymptote, pair of asymptotes with hyperbolas. Where are they? Well, the asymptotes are going to be through the corners of this box. Right, through the corners of the box. So the vertex is going to start at the point. Okay, and we're just going to come up here, and we're just going to hug our asymptotes. Okay, so come up here, down there, just going to hug the asymptotes. So we have the center, we have our vertices. What's the focus? Well, again, in this case, focus is c squared is equal to a squared plus b squared. So this is going to be c squared is equal to 16 plus 4. C squared equals 20. C is equal to plus or minus 2 root 5. Okay, so just to get an approximation of where this is, okay, second function 20. Oops, not 22, it's just 20. All right, 4.5-ish. Okay, 4.47, that's some change. So we have 1, 2, 3, 4.7. So here and here is going to be my foci. Okay, so see foci, and again, this is from the center. If you've got a hyperbola that's over here somewhere, it's from the center in the line of the vertices. Okay, so it's plus or minus 2 root 5, 0. Those will be my points. Okay, how do I find the asymptotes? Well, in this case, it's lucky. We're going through the origin. It doesn't go through the origin, we got a little bit more work to do. Okay, but in this case, we're just going to go through the origin. What's the slope? Right? It's a rise over a run, isn't it? So yeah, all my students are very, very fond of telling me this. So, and our b, our intercept, in this case, intercept is going to be 0. So we have y is equal to plus or minus, because we have 2 of them, each with opposite slopes. Okay, and what is our rise? 1, 2. And what is our run? 1, 2, 3, 4. So this is y is equal to 1/2 x plus or minus. And that is the equation of my asymptote. What if it goes in the other direction? What about part B? Right? Part B, okay, we have 25 and 64. Okay, so negative 20. Well, we have x squared over 25. Let's move this. 25 plus y squared over 64. I would usually swap them because it's just better to have the positive one first. But we'll set y equal to 0. Ignore negative. Okay, so we have x squared over 25 is equal to 1. X squared is equal to 25. X is equal to plus or minus 5. Okay, set x equal to 0. Okay, we have y squared over 64 is equal to 1. These don't have to be perfect squares, by the way. You just have uglier numbers if that's going to happen. We have y squared 64, y is equal to plus or minus 8. Okay, so actually I shouldn't have said uglier numbers. I should have said more delightful numbers. Okay. So let's go ahead and do this. Okay, so in this case, the vertices are going to be along y, so it's plus or minus 8. Okay, x is going to be plus or minus 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8. 1, 2, 3, 4, 5. 6, 7, 8. Okay, and we're just going to make our little rectangle here. And there's a straight. Okay. So again, we have asymptotes. Okay. Now, where are my vertices? My vertices are in the y direction. Okay, so we're going to go down here. We're going to go and hug our asymptote, and hug our asymptote. Okay, and hug our asymptote, and hug our asymptote. Okay, and it doesn't really matter. I mean, parabolas, I mean, hyperbolas could be very, very thin parabolas, right? Okay, they could be very wide parabolas. Okay, a very high positivity thing here. We don't really care if they're fat, thin, or between, or whatever. Okay, we're just going to go with whatever the shape tells us what it looks like. That's what we're graphing. Okay, don't have any sort of preference for anything here. It's just we're just graphing. Okay. And again, what is our right? We have y is equal to our slope, right? So what's our rise is 1, 2, 3, 4, 5, 6, 7, 8, and our run would have been 5. So plus or minus that x. What's the intercept? The b is 0, so y equals mx plus b format, and then we would have y is equal to plus or minus 8 fifths x. Those are the equations of our asymptote. All right. Foci. Okay, again, it's in the direction of the long one. Okay, the y part. So we have c squared is equal to a squared plus b squared. So this is what, 64 plus, what was my y1 or my x1 rather, was 65. Oh no, it wasn't. It was 25. What did I say? 65. 25. Okay. So what do we have here? We have 89 is equal to c squared. So c is equal to plus or minus root 89. Okay, and again, these are in the direction of the axis, the major axis. Okay, not the transverse, we want the major axis. All right. So let's get an approximation of well, 81 is like, the square root of 81 is like 9. So it's going to be a little bit more than 9. Okay. So we're here, it's going to be about right there, a little bit more than 9. This one, a little bit more than 9. Those are our foci. Okay, but that's how you go ahead and put a, this is 0 plus or minus root 89. Those are the points of our foci. Okay, so that is how you graph a, hyperbola. All right, now, what if I wanted to say put both my ellipse, this one, and my hyperbola, one of my hyperbolas, let's use this one, I know it won't fit. No. But what if we wanted to put two of these graphs on the same spot? This goes out 5. How about this one? This one goes out 1, 2, 3, 4, 5. So yeah, we're gonna have, we could have a hyperbola here, or ellipse here. So what if we do something like this? We do a x squared over 25 plus y squared is equal to 1. Okay, and then we'll do x squared over 9. We do, and minus a y squared over 4. Make that a y squared. Over 4. Okay, so we have an ellipse, we have a hyperbola. Do they intersect with each other? Okay, we could draw the conic sections and sort that out, but we've already done 2 of them. So let's just see what's going to happen. Okay, first thing I want to do, I want to make them so I don't deal with the fractions. Oops. So what I'm going to do for the first one is I'm going to multiply both sides by 25. Okay, what we did is multiply both sides by 25. That clears up the coefficient here, puts this at 25, tells that is 25. Here, we're going to multiply by 36. So we're going to get a 4x squared, right? 36 over 9 is 4, minus, we're going to have a 9y squared is equal to 36. Okay, so what do we do now? We have 4x squared plus, minus 9y squared is equal to 36. We have an x squared plus 25y squared is equal to 25. Most of the time with nonlinear equations, you are going to be substituting. Okay, it's just the way it is. Now, in this case, you don't need to do a substitution because notice we have x squareds and y squareds. We could eliminate one of these variables and not have to worry about it. Okay, so let's see, how do we want to do this? We could, I'm kind of lazy when it comes to multiplying. Okay, well, we multiply this one by 25, multiply this one by 4. I'm sorry, multiply this one by 9. That's what I meant. Okay. Notice I don't have to worry about the signs, SIGN signs, because 25 times 9 is going to be the same thing as 25 times 9. And we can go through and do this. So 4 times 25 is 100, x squared, minus, if I have 9 quarters, I think that's 225, right? And then, oh, I don't know what 25 times 36 is. I think it's 900. Right, because this is 6 times 6 times 5 times 5, so this is 30 times 30, which would give me 900. Okay, so here we're going to have 9x squared. Okay, this is going to be 25 times 9, that's going to be positive 225y squared, and is going to be 225 over here. Okay, when we add them, we get 109x squared is equal to, what is this going to be, 5 to 1125? So we're going to have x squared is equal to 1125 divided by 109. I seriously doubt that that reduces. We can check. Okay, 1125 divided by 109. And we can turn it back into a fraction. So let's go to math. Turn it into a fraction. Yeah, we got nothing. Okay, that's it. So neither of those are perfect squares, so we are kind of screwed. So this is equal to positive or negative 125 over 109. Okay, now the easy part, but the tedious part. Okay, pick any one of these problems. Okay, pick any one of these. The previous ones we've had. Okay. Yeah, I'm going to pick this one. Okay. So we're going to go back to x squared plus 25y squared is equal to 25. What's x squared? Well, x squared is 1125 over 109 plus 25y squared is equal to 25. So we're just going to subtract. Okay, this is going to be 25y squared is equal to 25 minus 1125 over 109. Okay, I kind of wonder what that's going to give us. So this is 25 times 109. So we got 2725. So this is 25y squared is equal to, here we have 2725. 2725 minus 1125 all over 109. Okay. Well, part of doing this was to get a common denominator. Okay, 2725 minus 1125. So we got 1600. So we have 25y squared is equal to 1600 over 109. 1600 divided by 25. So we have y squared is equal to 1/25 times 1600 over 109. What is 1600 divided by 25? I should know this. Okay, divided by 25, being terrible, 64, of course it is. So y squared is equal to 64 over 109. So if we go through and find out what y is equal to 8 over the square root of 109 plus or minus. We could rationalize the denominator, but since this is a very symmetric value, right, you can kind of see it in your head where we're going to have an ellipse, okay, and then we're going to have a hyperbola, okay. So we're going to have our intersection points, right? So it's going to look like something like, it's just going to be these things mixed up and matched. So we have 1125 over 109. So this is 1125 over 109. We have a positive 8 over root 109. That'll be the one in the first quadrant. The one in the second quadrant is going to be negative 1125 root over 109. And then positive still, so we have 8, 109. Our third quadrant value is going to be both of them are negative. There's no prescribed way, like you don't have to write it down in the same order I did, okay? And then quadrant 4, okay, is a positive 1125 over 109 and a negative 8 over the square root 109. Okay, and those would be our points of intersection that we would have here. Okay, so if you can graph it, please do, because it does help you get a count of how many solutions you should have. Okay, but a lot of them, like, and when I say graph, I mean about as well as I did. Okay, you don't have to make a great graph out of this, just like a little sketch of like, what am I looking at, right? Because it does help. Okay, but sometimes it's not really possible. If you have x, y terms in here, what you're going to have, like 1 over y is equal to 1 over x. This is x, y is equal to 1. This is technically a hyperbola. This is my axis. Okay, so we have our asymptotes here. Okay, we have one little box here. So I should say a little. This would be my box. So the asymptotes are just the axes. Okay, and we would come through and do something like this. This is okay, but there's no way you're going to draft something like this. As soon as you put an XY term in there, you've got a conic section that's kind of tilted, and that is definitely for another class. It's really cool, but it's definitely for another class. Okay, but that's how we do that. Okay, so we'll let you go with that, and that is how you graph conic sections, and that is how you deal with nonlinear equations, systems of nonlinear equations. All right, good.